Okay, let's get started. What we're about to do is first multiply and then simplify whenever we can. And remember the rules of multiplying radicals. We have one radical out here and another radical out here, and we're multiplying them together. It's very inefficient to write them separately, so what we like to do is combine them. And if you combine them, they just go under all one radical. It's just like you would do in fourth grade. If you have a 3 times a 4, you wouldn't leave it like that. You would just multiply the two together to get 12. We always like to combine things when they're being multiplied. So let's try a few in here. So if we have radical 5 times radical 11, that is the square root of 55. And I ask myself, can that be simplified? I'm always checking the factors of 55 to see if any factors are on that list of perfect squares, and the answer is no, so that's my final answer. Let's try another one. Well, we have radical 16 times radical 14. I can certainly try to push those together. 16 times 14, I think, is 224. But if you notice, this is a perfect square. So that is like 4 times radical 14. And so in this case, I can't mush them together because one's in a radical, one's not. And that's my final answer, since radical 14 cannot be simplified from our list in here. The next one here, I have a variable and a number, so that's going to be the square root of 5a, and I can't simplify that any further. That's the final answer. In this case, we have 3 here being multiplied to this group, 2x plus 5, so I hope you can see the distributive property. What would that look like? Well, that would be 6x plus 15. Okay? And that can't be simplified anymore as well. Same thing in here. If I combine these two, this is going to turn into the square root of x squared plus 2x, and that can't be simplified anymore. The next one, it's 3 times a half. Well, another way to say 3 times a half is 3 times 1 over 2, and so that's the square root of 3 over 2. Now, we're going to leave it like that for now, but we'll learn later on in this chapter that that's not an acceptable way to leave radicals, but we don't have enough technique yet to be able to conquer that. The next one in here, I have 2 binomials in here, so when I combine them all under one radical, that's going to be 9 minus a squared. All right, take a look at foiling in there, and when you FOIL, you're going to get that expression right there. Same thing in here. When we FOIL these 2 binomials, it's going to be x squared plus x minus 12. Make sure you really are comfortable with your foiling skills. And then these last 2 binomials here, when I multiply them together, that's going to be 2x squared. Whoops. Let's erase that. I got 2x squared. Now I look at 3x and 2x, that's 5x, and then 3 times 1 is 3. So it didn't really seem like any of these could be simplified. I think the main idea in these group of 9 problems, we were just trying to multiply and combine them so we don't have as many radicals. All right? We'll try another few more problems in the next video.